We're going to begin with operations and polynomials. And when we talk about polynomials, we're talking about something that has many or multiple terms or numbers in it. So let's see examples of those. So if I gave you something like 3x squared plus 5x plus 4. This is a polynomial because it's made up of separate terms. And in this case, we look at all the operations connecting them. We have a plus and a plus. So we have two addition signs, which means that there are three terms here. First term is 3x squared, second term is 5x, and the last one is 4. So this is a polynomial where poly means many, and we could put a more specific name onto it if we want to. Three terms would actually be a trinomial. Still a polynomial because it has many terms, but tri for 3. Another one. Let's say we had 10x to the 4th minus 6x to the 3rd. So we can either look at the terms or look at how many operations there are. We have a 1 minus sign, meaning that there are two terms here, the 10x to the 4 and the 6x cubed. It's still a polynomial, more than one term. Specifically, we can call it a binomial. All right. Now, if there's only one term, it wouldn't be a polynomial because poly means many. One term would be a monomial, all right, just being one term. So what we're going to do is piece together these polynomials using different operations, adding, subtracting, and multiplying. So for example, let's say they gave us 6x minus 2 plus 8x minus 5x squared. Okay, so a couple things going on here. I've got a plus sign, but let's look at that piece by piece. Up here, there's also two terms because they're connected by a subtraction sign. Over here, another two terms connected by a subtraction. So we have two polynomials. All right, 6x minus 2 is a polynomial, and x or 8x minus 5x squared is also a polynomial, and then we're going to add those two together. So we're adding polynomials right here. And when it's adding, the parentheses really don't matter to us. We can kind of ignore the parentheses and we're just combining like terms. So let's see. We can just go ahead and grab anything. So I have 6x. That's 6x to the 1. We need to match that with any other thing with an x, any other like terms. So the other one is that 8x to the 1. So 6x to the 1 plus 8x to the 1 is 14. And then we keep it x to the 1. And we don't need to change that. All right, so once we have it, it's kind of good to cross those out. I'll work my way over. I have a minus 2, a negative 2. And are there any other terms by themselves known as constants? Nope, so negative 2 just gets pulled down. And the only thing left now is this negative 5x squared. There's nothing else to go with it, so we'll bring it down. Now technically we have combined everything together, all right, but we want to order these a little bit better. We want to go from the biggest exponent to the smallest. That's how we want to arrange them. So we're looking at these, the biggest exponent is x squared. So let's write that term first, the negative 5x squared. The next one would be the 14x. It's a positive, so plus 14x. And the last one's a minus 2. And this is called standard form. Remember, standard form is putting it from biggest exponent to smallest exponent. That's our final answer there. Now, both answers are correct. We just want to put them into standard form from now on. So let's take a look at another one. So, for example, let's say they give us y squared minus 3 plus 4y to the 4 plus 2y minus 4y squared minus 8y to the 4 plus 4, so pretty lengthy here. So we look at it. We've got a polynomial here, a polynomial here. First one's a 3-piece, a trinomial. Second one's a 4-piece. Okay, so it's a 4-piece polynomial, and they're being connected with addition. So when it's addition, we just combine like terms. Now I could start going from left to right, but I know I want to get it into standard form eventually. So let's go ahead and start with that. Let's look for the biggest exponent altogether. So biggest exponent possible is this 4, y to the 4. There's another y to the 4 here. So those ones are like terms, and they're the biggest. So let's start with that. So a positive 4y to the 4 minus, positive 4y to the 4 plus a negative 8y to the 4. So 4 minus 8 really is negative 4y to the 4th. We keep that exponent, use it, cross it. So I did y to the 4. Are there any y to the 3's? No. Let's work our way down. Next will be y to the 2. So I've got a 1y to the 2 and a negative 4y to the 2. Let's add them together. So 1 plus negative 4 is a negative 3y squared. We keep that exponent. So I've done y4, y2. Now let's do y by itself. That would be the 2y right there. There are no other y's to go with it, so let's write it as plus 2y. And then finally, let's find everything without y's, the constants. Negative 3 plus positive 4 gives me a plus 1. So we've saved ourselves a step by putting into standard form first. Everything is combined. I can check once again, y to the 4, y squared, nothing else is like terms, so there's our answer after combining them using addition. So we've seen a couple of addition ones. Let's go ahead and take a look at subtraction. So for example, a 7x to the 4th plus x to the 3rd minus x to the 4th minus 1 minus 4x cubed. All right, so it looks very similar. We've got a binomial here, a trinomial here, connected this time though with subtraction. Now we don't really like subtraction, but subtraction is kind of like addition, and I'll show you why. What we're going to do, you notice here we've got parentheses with a negative sign outside of it. Technically it's a negative 1, and it's being connected by multiplication. So what we're going to do is take that negative sign and apply it to everything in here, distribute it to everything after it. Gets applied there, gets applied there, gets applied there. So we're not going to change the first one at all. So let me rewrite the first one, and we're going to drop the parentheses. 7x to the 4th and x to the 3rd. From there, I'm going to follow the signs. So we're going to have a negative 1 times this term, x to the 4th, so that's a negative x to the 4th. The negative 1 times this negative 1 is a positive 1. And then finally, that negative sign applied to the last one makes it positive. So all that negative sign did was change the signs of everything after it. Okay, so this negative sign changed the signs of everything afterwards. And now, since the parentheses are gone, we can combine like terms. But again, let's start with the biggest exponent so we can make it standard form. So we got 7x to the 4th and negative x to the 4th. So 7 and a negative 1 makes a 6x to the 4th. Let's keep going. I did x to the 4th. Now we've got x to the 3rds. 1x to the 3rd plus 4x to the 3rd is a 5x to the 3rd. And then that 1 is all by itself now. And we take a look, we have combined all like terms. There's nothing else we can do to this. So we box it, and there's our answer. So the thing to remember here on subtraction, we want to be able to change that negative sign or distribute that negative sign to everything after it and go from there. Okay, we're going to flip those signs. So let's see another one. Let's take 3x to the 4th plus 5x squared minus 5x squared plus 6x cubed minus 5x to the 4th. All right. So another way we can do it is think about applying this to everything after it. So it gets applied here, changes its sign. It gets applied to the 6, changes the sign. It gets applied to the 5, changes the sign. But once we flip it, now this is a plus, and we don't have to worry about it anymore. Remember, once we distribute it, we don't have to worry. So now let's take the biggest exponents. 3x to the 4th and 5x to the 4th make 8x to the 4th. So I'm just following the signs now. Positive 3 plus positive 5. Gone and gone. Next, biggest exponent is this x to the 3rd. There's no other x to the 3rd, so let's write it down. Negative 6x to the 3rd power. Gone. And now finally, I've got positive 5x squared minus 5x squared. So a positive 5 and a negative 5 actually just cancel each other out. We could write a 0, or we don't have to. It's probably just better looking to leave it like this. That term canceled out. So the thing to remember, if it's positive, we can go ahead and write and combine the like terms. If it's negative, we want to apply that negative sign to everything afterwards.